Hello students. This lecture is addendum to the study material which I provided regarding the two resistance theory or two film theory. So in this lecture we will talk about two film theory or two resistance theory in mass transfer, or in the case of interface mass transfer. So in order to understand this, the concept of two resistance theory, you have to look at the study material I provided, and along with the study material, this video lecture will help you to clear or clarify the concept of two film theory in the mass transfer, or in the case of interface mass transfer. So, like in the previous lecture, I talked about what is the interface mass transfer and what are the concepts of equilibrium. So let me just summarize the idea about the interface mass transfer that was discussed in the previous lecture. So I talked about interface mass transfer between two phases, and I said from chemical engineering point of view or from industrial point of view, we have a mass transfer mainly between two phases, that is from gas phase to liquid phase or from liquid phase to gas phase, and we had several examples for the interfacial mass transfer like absorption and distillation in chemical industry. In today's lecture, I will focus on two film theory. So let us come back to two film theory. So again, we have two phases. We have gas phase and we have liquid phase. So if you look at the figure 3.6 of the study material I provided last week or a couple of days back, so you see this we have two phases. In the left hand side we have gas phase, and in the right hand side we have liquid phase, and we have an interface which separates the two phases, gas phase and liquid phase. And mass transfer of a component will be from gas phase to liquid phase. So component A will move from gas phase to liquid phase. So this movement will be completed in three steps. In first step, component A will move from bulk of the gas phase to the interface between gas and liquid, and then it will move from the interface and it will cross the interface in the second step, and then it will move from the interface of the gas and liquid to the bulk of the liquid phase. So this theory is called as two film theory, and why this theory is called as two film theory is because if you look at the graph or concentration profile of solute A, which is diffusing from gas phase to liquid phase, you can see that concentration of A is almost same in bulk of the gas phase, but it is sharply reducing or sharply varying near the interface towards both gas phase and towards liquid phase. So this is because as per this theory, and I also explained this in the class, in case of interface mass transfer, we have two film which will be there in this case. One film will be towards gas side and other film will be towards liquid side. So this interface will separate two different films, one film towards gas side and other film towards liquid side, and across the film all the resistance to mass transfer will lie. There is no significant resistance in bulk of the gas phase and bulk of the liquid phase, and resistance will be only in the film near the interface. One film is towards gas phase, one film is toward liquid phase, so we have two film, and resistance will lie in these two films. That's why this theory is called as two film theory, and as per the table, this film is also called as two resistance theory, because we have only two resistance. And as per this theory, it is assumed that there is no resistance to mass transfer across the interface. Only resistances are in the film lying both side of the interface, one towards gas phase and one towards liquid phase. And that is also clear from the concentration profile of A. If you look at the concentration profile, you can see that concentration of A is reducing sharply from YAG to YAI, near the interface, which is inside the film. And again, towards liquid side, concentration of A is again reducing from XAI to XAL, uh, and after that it is almost not varying, almost flat. So you can see this sharp decrease is near the interface, which means that near the interface towards both sides we have two different films. This side is also we have film, liquid side also we have a film, and gas side also we have another film. And that's why this resistance, this theory is called as two film theory or two resistance theory. So for this two film theory, the assumptions are uh, there is no resistance to mass transfer in bulk of the gas phase and bulk of the liquid phase. That is first assumption. And second assumption is there is no resistance to mass transfer at the interface, and all the resistance lies in the film. In two film, one is towards liquid side, another film is towards gaseous side. That's why this theory is called as two film theory. So if you look at the graph, YAG is the concentration of A in bulk of the gas phase, and YAI is the concentration of A at the interface. XAI is concentration of A in liquid phase at the interface, and XAL is concentration of A in bulk of the liquid. And here XAI and YAI, where YAI is concentration of A at the interface in gas phase, and XAI is concentration of A at interface in liquid phase. So here YAI and XAI are interfacial concentration, and these are the equilibrium concentration. It means these two follow, YAI and XAI will follow the equilibrium relationship which was discussed in the previous lecture. Like this will follow the Rolle's law or Henry law or any equilibrium relationship that is applicable for this particular case or this particular case of mass transfer. So this is regarding to film theory. So if you want to write the mass transfer equation or flux of mass transfer for this, so for gas phase you can write Na is equal to ky, which is mass transfer coefficient in gas phase, Na equal to ky times yag minus yai. And again for liquid side we can write Na is equal to kx times xai minus xal. And at a steady state, when there is no accumulation of A at the interface, both the flux inside the gas phase and towards the gas phase and towards the liquid phase will be equal. So ky into yag minus yai will be equal to kx into xai minus xal. And after rearrangement it can give the equation, which is yag minus yai divided by xal minus xai, and that is equal to minus kx upon ky. So this lecture is was completely focused on two film theory. You must go through the study material and as well as the textbook that I suggested, like Travel or BK Datta. And then this lecture is just the addendum for this material which I provided. And for we as we are doing for discussion or for any doubt clearance, I will be online on Blackboard. You will be given the link, and you can come online and you can ask the your doubt or clear your doubt. Thank you.